Okay, we've gone from a nice question about rotational dynamics to a much harder one, I'd say. We've got a car of total mass m traveling with constant speed. We know that each of the four wheels of the car has a mass m and a radius r, and it rolls without slipping. That's a specific condition in physics. Moment of inertia of each wheel is I equal to half mr squared, and we want to know the sum of the rotational energy of all four wheels over the translational kinetic energy of the car. Nice question here. I've seen IAs on this topic. Let's have a go, and then when you're ready to see the explanation, please hit play. Okay, let's go for it. So first thing to think about, okay, we've gone in for a nice bit of maths here. We're going to look at the rotational kinetic energy firstly. The rotational excuse me if I can say it, the rotational kinetic energy is given by a half I omega squared. Okay, now in this case we have to do a little bit of maths. We know that we've got n wheels, in this case n is 4. We've got a half here, and then we've got our moment of inertia, a half mr squared. So what I've done here is I've substituted I in here, half mr squared. And we can then look at the maths there. We've got 4 times a half. Actually, those numbers are going to cancel out. We've simply got mr squared omega squared. Okay, so this is the total kinetic energy of all four wheels. I've left it in that way because we're going to then do something else. We're going to look at the translational kinetic energy, which is the total energy there. All we're taking is the total mass m times v squared. Now, in the non-slip condition, we can replace v with omega r. Okay, v equal to omega r is true for non-slip. And so in this case, we've taken our v squared and replaced it with r squared omega squared. Hopefully you can see we've done that because we've got an r squared omega squared and we want to cancel them. None of our answers have r or omega in it, so they better cancel. What we'll do here then is we'll find that the rotational energy is divided by our total translational energy, and we've got 2m over capital M. We've got an r and an omega, our r squared and our omega squared cancelled, and we've got 1 over 2 here to bring the 2 on the top, which means our answer here is C.